All right, everyone, we are going to get started now. Welcome, everyone, and thank you for joining us both in person and on Zoom for this ETI Emerging Technologies Institute at Foothill College sponsored workshop on blockchain and Web3 here today. My name is Zach Semblin, and I am the interim dean of the STEM division at Foothill College. And I have worked at Foothill College for about 15 years now, with the majority of my time teaching mathematics at the college. I'm happy to be here for today's presentation. Firstly, I want to make sure that we welcome our guest speaker and say thank you to our presenter, Matthew Polland. Thanks for being with us here today, Matt, and we look forward to your presentation.
Absolutely. Thank you, Zach.
Now, as we will be venturing into our discussion about blockchain and Web3 technology, I wanted to first take a moment to briefly introduce our speaker. Matthew has 21 years of experience in serving diverse populations through workforce development programs that help people access quality work opportunities. Since his early days of crashing his dad's computer to electrical engineering courses in college, Matthew has always kept up with the latest technology trends. In late 2021, he began researching and working in Web3 to learn how to make these new work opportunities more equitable and accessible to all. Matthew is the founder and principal of MAP Advising, MAP, a consultancy focused on preparing organizations for the future of work. He has most recently worked on projects with ICF, Safal Partners, Empower, 418 Intelligence and Jobs for the Future, otherwise known as JFF, amongst others. Prior to JFF, he managed a work-based learning intermediary for youth at the United Way of the Bay Area in San Francisco. Matt holds a master's degree in public administration from San Francisco State University, and he also has a bachelor's degree in psychology from the University of Michigan. So, with that being said, let's all welcome Matt to Foothill College, and it's all yours, Matt. Thank you once again.
Great. Thank you, Zach. I often don't get the full introduction, so I appreciate that. So everyone knows plenty about me now. It's great talking to you all. And like Zach said, my work has been in the workforce development space, kind of helping with developing training programs and getting people to work. And what I try to do is pay attention to technological trends and how they're changing work. And Web3 and blockchain, I think, is something special in that space and how it's changing work kind of under everybody's noses, I might say. And so I've been trying to kind of research it, learn about it, and share what I'm learning, both the people and folks in my field, as well as students and job seekers and so forth. So I'm excited to be here to share what I've learned so far. I do apologize in advance. I'm also taking care of our high maintenance puppy. Might have to check on him from time to time. I was hoping he'd be tired out by now, but unfortunately he's still wandering around. So I might have to go check on him every once in a while. But let's get started.
Thank you, Matt. And one thing, if I will,
Yeah.
folks both on Zoom and in the crowd, if you do have any questions throughout, just make sure you ask that in the chat. If you're here in person, just raise your hand so I can make sure to unmute you and you can ask your question. Thank you very much, and go ahead, Matt.
Yeah. So just wanted to say GM, that is a term used in Web3. It's short for good morning, but people use it at all times of the day because there's folks in Web3 working together all around the world. Everyone's in different time zones. And so GM has just become kind of a standard greeting in the Web3 space. So yeah, as Zach said, I'm happy to answer questions as we go along. I also have space at the end after you've heard the whole presentation to have questions as well, but please feel free to stop me. Zach, you probably will have to help me if there's like a question in the room. I can't see the room very well. I can see I can sort of see it. There's a split screen thing going on your screen. And I'll try to pay attention to chat too. I've got that up on my screen, so I should be able to see if anyone drops a question in the chat. So also let me know if you're on chat or you're on Zoom, if there's anything specific you want to learn as we go along here. Again, we're going to go over blockchain, cryptocurrency, and humans, like how humans are an important part of the whole Web3 ecosystem, a very, very important part. And we'll go from there. So you've heard most of this already. I've been in the field for 21 years in workforce development. And the reason I came across this is because I think Web3 and blockchain in particular are really changing work and jobs. And we'll kind of dive into what that means for you as students, potential job seekers and so forth. So the basic high-level topics we're going to cover today, broad overview of Web3, the concept of decentralization, which is really important for Web3 and blockchain, a blockchain overview, the basics on cryptocurrency, and then, of course, humans in Web3 and why people are still very, very important. Yes, there's things becoming more automated. Yes, there's AI and things being used, but that's not going to replace humans anytime in the next I don't know how many years. So it's still very, very important that humans be involved in shaping it the way we want to see it created and how we want work and jobs to look in the space. And I also want to touch on risks in Web3. So if you do get involved and you do want to work in the space, there's of course risks. It's a new area. Some people call it the wild, wild west. There are risks. So I always make sure to let people know what some of the risks they should be aware of are. What I'm not going to cover today is training for a specific job or opportunity. Just want to be clear that this is kind of a very high level discussion of these topics. And I do have other courses I've done where go a little deeper in each one, but I'm not training for a specific job or work opportunity. And even though we're talking about cryptocurrency, we're talking about cryptocurrency with its respect to it being a tool that helps blockchains function. And we're not going to be talking about any kind of financial advice or the latest meme coin you should buy or not buy. That's not going to happen today. What I'm hoping is by the end of the workshop, you'd be able to explain to someone in broad terms what Web3, blockchain, and cryptocurrency are. Understand the purpose and function of a smart contract. So that's a really important development in blockchains in the last 7 years. Identify some of the risks in working Web3 and know where to learn more about it. So any questions so far before I jump into a broad overview of the Web3 world? Okay, not seeing any. Is there a question, Zach?
They're thinking about it.
Okay.
Yeah.
It's okay. We can keep going.
May I ask a question? So, the focus is about Web3, blockchain, cryptocurrency, but what is in the center, or is all three important, or like the blockchain is important, and then based on that, Web3 and cryptocurrency works, or how should I understand the relationship between those terms, those ideas?
Yeah, hopefully it will become clear as I talk through it how they're all related. Web3, I'll just quickly say Web3 is kind of a term that covers everything happening in blockchain and cryptocurrency and the organizations and people forming companies in the space. Web3 is a very broad term. Blockchain is a specific technology that is part of it and how a lot of things operate within Web3. Cryptocurrency is a tool that's part of how blockchains operate, what allows them to operate. Is that helpful so far? And hopefully as we go along, it'll make more sense.
And one question I got in the chat, Matt, is what do you need to know to start off in this world and environment as a newbie?
Well, I'm hoping it'll be a lot of what's in here as a starting point. And then you can, from there, you can kind of pick like, I think I want to know more about this or that specific subject and go deeper. And I have some resources for that at the end. All right. Okay, so let's talk about Web3. Again, kind of the broad concept of all of the work that's happening around blockchain and cryptocurrency. So to talk about Web3, we have to talk about what Web 1 and Web 2 were. Or back then they were just called Web 1.0 or Web 2.0. So Web 1.0 was basically some have called the read-only web. So this is going back to the 1990s, up to 2000, 2002-ish. There's about 100,000 websites at this time, and you have folks like MSN, Yahoo, AOL, mostly pushing out published content. So people like you and I were mostly consuming content. We weren't interacting too much. You see this arrow, the published content's the big arrow. It was mostly just pushing static information and websites to people who are using, who are consuming that information, but very few people were publishing themselves or interacting in any way. Next is Web 2.0. So this is, early 2000s, definitely by the mid to late 2000s, we were fully into Web 2. And, the number of websites explodes. And you start to, what's really important here too is the birth of e-commerce, of people buying stuff online. The 1990s, maybe it's just starting in the late 1990s. I think Amazon was 1999 or something. People weren't buying things online. That wasn't happening. So early 2000s is when people started buying things online through Amazon and others. But people are also more interacting. People are publishing their own content. YouTube is born in, I think it's around 2008 or 2009. It allows people to kind of publish their own video content. And so there's still a lot, the majority of it's still published content that we're consuming, but people are starting to interact more. So you see that blue arrow coming back with the people that are publishing themselves and users that are interacting and publishing themselves onto the internet. What's kind of important too about Web 1 and 2 as we talk about Web 3 is even though people are publishing content, the content is still owned by these major companies and, like Facebook. We'll talk about that a little bit more. You don't own your posts on Facebook. Facebook owns them. Facebook is a centralized entity. So all of this, even though we're publishing content, it's very hard to kind of take ownership of it and to generate, value from it, to capture value as a user, as a publisher even. The big guys they still to this day, capture the vast majority of the value from the online content that's published. So Web3, what Web3 is about is user-owned content and more peer-to-peer interaction without intermediaries. So Facebook is an intermediary. YouTube is an intermediary. We're interacting through their servers, through these companies as a centralized entity. In Web3, there's a lot more peer-to-peer networking where we can interact with each other directly. We can share with each other directly without going through intermediaries. And I have some examples of decentralized organizations that are in Web3, like Polkadot, we'll talk more about, DAI, OpenSea, Ethereum, we're going to talk a lot about. That's a very important decentralized network, and it's a blockchain. But as user-generated content, the other ethos of Web3, or at least the version of Web3 that I subscribe to, is user-owned content. So if you publish something, you should be able to own it, and you should be able to capture the majority, if not all, of the value from it, instead of that being captured by a centralized corporation like Facebook or Google or Amazon or YouTube. So we have them off to the side. So one version of Web3 is the decentralization becomes more important. Now, YouTube, Facebook, they're all still there. It's still going to be there for a long time. but they're not as they're less they're not central to Web3. They're their own private networks is what they are. So this is another way to kind of visualize it and also get at the decentralization concept. So in Web 2.0, when we use Facebook, if you think of all of the users, all of us on Facebook, all the users are, this could be Snapchat, this could be Instagram, this could be any of those, right? I'm just using Facebook as an example. We're all the dots on the outside. We don't interact with each other directly. We interact with each other through Facebook servers, through a centralized organization. That's why Facebook is there at the center. In a decentralized network, an example of a decentralized social media network is called Lens Protocol, or they have what's actually called Lenster. Everyone operates through these nodes. Now, Lens, where you see it at the middle, these nodes are all on equal footing. There's no centralized server. These are basically like clusters of users that are using the Lens protocol, and they are interacting directly through the protocol, but none of these are a centralized company or server. It's a decentralized network, so that users can actually interact directly with each other and own their content. So on Lenster, you own your content when you post it, and you get to decide what to do with it. Lens is not a company; it's a protocol. So you decide what to do with your content. You own it. If you monetize it, you capture the value. So again, so why the move to Web3? Why are people building this version? People calling Web3 a different new version of the internet. They're it's an internet owned by the users through the concept of decentralization that we just talked about. People cared about individual ownership of digital assets. People care about transparency. Facebook, Amazon, and YouTube are black boxes. None of us know what's really in the algorithm. We can take guesses or play with it, but we don't know. They're controlling how our content is posted and used and shared, and we have very little knowledge of how that happens or when it changes or why it changes. Web3 is much more about open source and transparency and knowing what's happening in a network. Everybody has on equal footing. There's more, symmetry of the information happening there. It can be an easier way to start a business. There's less barriers. There's a lot of people that have created businesses on Web3. And all of this was made possible, with the invention of blockchain. And as many people know, the first blockchain was Bitcoin. And the reason Bitcoin was invented is because people thought there should be a way to send money digitally to one another without the use of the bank as an intermediary. Especially when you're sending to other countries, there's large fees captured by banks, and that people thought we should be able to send money to each other anywhere in the world instantaneously online and not have to go through a bank. We should be able to do that peer to peer. That's why Bitcoin was invented. Why should you be interested in Web3? It's already shown a lot of promise in developing all sorts of new work opportunities. And this is the main reason that I've become more interested in it. In my research on Web3, I've seen gig and regular employment opportunities. So people are 1099 contractors. They're also regular W-2 employees. There's obviously jobs in coding and development, but there's a whole slew of other jobs that support the technological part. So even if you're not someone who is deep into the technology, or you're not a software developer, maybe some of you are, but if you're not, there's design opportunities, UX and UI, a lot of that actually, because the interfaces were clunky and hard to use, and design and user experience became very important in this space. Writing and editing, marketing, community management, project management, research and finance, and entrepreneurship opportunities. There's a lot of this happening. It's really a kind of growing part of our economy. And in my opinion, it's not so much, is it going to be a part of the economy? You'll hear that still too. Is crypto going to die? Sometimes people use crypto for this when they mean Web3. It's not dying. It's only growing. So it's really only how much of a part of our economy is it going to be in 5 or 10 years? Not if it's going to be there. It'll absolutely be there, in my opinion. It's whether or not it'll be 1% of the economy or 5% of the economy or 10 at some point. So next, I plan to go a little deeper into blockchain, but I will again pause to make sure I cover any questions so far. Is this making sense kind of at a conceptual level?
We do have one question in the chat to begin with.
Okay.
Yeah.
Oh, okay. So what I felt from this information is that it's kind of enhancing the individualism because decentralized and like project-based, this isn't allowing people that don't have that skill in designing, marketing, or finance, while centralized can um, train people to get better, I guess. So what is your thought about this new work opportunities to action?
Are you asking why is it better than traditional opportunities?
I feel that this is better for people who are skilled in these areas. They can get the number of opportunities. But for those that are starting or not really having skill, it might be not unfair, but that can create gaps. That is my
Yeah. Well, let me, you're right. I mean, and let me say, this isn't an exhaustive list. This is just the scratching the surface, I think, of the opportunities. Yeah, you would definitely have to learn some skills in any of these areas as you would if you wanted to get a job in marketing at a regular, at Amazon. Yeah, you would have to have some marketing skills or background. And I also don't mean to say these are necessarily better. Maybe they will be at some point. It depends on your situation. What if it's better to get a traditional job or to try to pursue something in this? Again, like the reasons you might want to do that is a little bit more independence, and ability to do gig work. If you prefer to do gig work instead of a W-2 employment, there is already, and there's going to be a lot more of that in Web3. But it may not be for everybody. That's true. I'm not saying it's better for everybody. I don't mean that to be the message. Okay, do we have any more questions, Zach, or should I move on?
Not in the crowd. Any other questions on chat and Zoom?
I got a simple question.
Oh.
Will that PowerPoint be available just as a reference for us?
Did you hear that, Matt?
No, I couldn't hear that.
The question was if the PowerPoint would be available offline for.
Yeah, I can make this available after the workshop. Absolutely.
Okay, great.
Yeah, and I have some links in here too that you'll want. So
cool. I think we're good then. Let's move on.
Great. So thank you for the questions. Keep them coming. And let's dive into blockchain. So let's pretend it's the early 2000s. There was a lot of discussion at the time, again, on how to create a form of digital money that could be spent person to person, like I talked about before, without a bank or a government involved. People thought we should be able to send money, without having, to use a bank as an intermediary. You may or may not know when you send money digitally, it goes through something called the Swift banking system. It's very slow and clunky and takes days to clear transactions. It's really inefficient. And then there's also a lot of businesses that make money on the way, right? And so folks that were saying, why can't we just be sending money somehow, like find a way that we can share value, we can pay each other, we can share money online without a bank. So that was the problem they were trying to solve. How do you create a form of digital money that doesn't need banks or governments to be used, that we can be a direct peer-to-peer digital form of payment? The biggest problem in that is what they call the double spend problem. If you don't have code, if the code you use to create digital money is not secure, it can be exploited, and a user could keep spending their same digital money over and over. Their $100 it can be used many, many times. If you gave them digital $100, you didn't have a very secure way of tracking whether they spent that money or not. You would have what they call a double spend problem. You don't have a way of showing that someone spent their money and it's no longer, they no longer have it in their wallet, right? You need a way to keep track of it. So just a little background on some of the concepts that came together to create Bitcoin, which was the first blockchain. In 1990, there was a paper that came out, and it was about stamping digital documents. In that case, they were solving a different problem. It was, how do you, this is 1990, there's starting to become more digital documents that people are using and sharing. And the problem they were trying to solve is, how do we know when someone created something? If they said they created it last week or last year, how do we prove when, is there a way to prove when a digital document was created? And so they did it through this using blocks of data, like basically the basics of a digital ledger. So this is some of the stuff that came into creating Bitcoin, the first blockchain. And the other part is the proof of work model. And this is a really interesting part and a very important part for the security of blockchain. And it came from email. So 1999, a lot more people have email addresses, and spam has become a huge problem by 1999. And people were trying to figure out, how do we stop people from spamming so much and sending so many emails? And the proof of work model basically means that it would cost people something to send email. It got implemented a little differently, but the idea was that if the email costs like a fraction of a cent, you and I don't care when we're sending a couple of emails a day. It may not even cost us a cent, but if someone's sending tens of thousands or hundreds of thousands of emails a day, it starts to become very costly for them to do it. And so the proof of work model forces it to take time and energy and dollars to complete an activity online. And that's where the proof of work model came from, is battling email spam. And it's an important concept for the first blockchain, Bitcoin. There's other consensus mechanisms now, but just going a little bit further, 2004, the proof of work model, as a POW, is updated by Hal Finney as a mechanism for verifying transactions and reaching network consensus. But most importantly, just jumping ahead a little bit, 2008 is when a paper comes out by Satoshi Nakamoto, which we know is a pseudonym. We don't know who he or she or they are. It could be a group of people. We know it's Satoshi Nakamoto. Is not a real person. That's all we know. But put out a white paper that combined the timestamp blocks, proof of work model, and the digital signature concepts into the creation of Bitcoin. So they put out this Bitcoin white paper. And then folks, soon after the white paper, actually built it and made it happen. And it was launched in January 3rd, 2009 with what they call the Genesis block. And so Bitcoin was the first example of blockchain, but now, and we'll get to more of this later, there's a lot of different blockchains, and there's a lot more different functions. All the Bitcoin blockchain does is keep track of Bitcoin. Who has how much Bitcoin, when was Bitcoin sent from one person to another? That's all it does. There's a lot more being done now with blockchain, which is what makes it really interesting. But at its core, it's a distributed ledger technology. And kind of an important thing to note is it's not programming language. It's a concept and a protocol. So it's kind of like a way of doing things with code. There's different programming languages that can be used to actually make it work. But it's important to know it's distributed. So a given blockchain exists in thousands of locations simultaneously. That's also part of the decentralization. So the Bitcoin, just using the Bitcoin blockchain again as an example for now, does not exist in one place. It's not on one server. It's not on 10 servers. It's on thousands and thousands, or even more than that. That's how many servers. It's copied everywhere. So if a group of those servers went down, it doesn't matter. The copy of the entire Bitcoin blockchain is available in many other places. It's a ledger, so it's an unchangeable history of transactions. So again, the function of the Bitcoin blockchain specifically is just to keep track of Bitcoin. There's exactly 21 million Bitcoin available. And from the beginning, they pledged it will be never any, the network has agreed that it will never be more than that. And the blockchain keeps track of who has how much of it at any given time. And finally, when we're talking about Bitcoin, and later we'll talk about Ethereum, they're public blockchains. There is such thing as a private blockchain, but it's kind of an odd offshoot of this whole world. So I'm not going to be talking a lot about private blockchains. Primarily what we're interested in Web3, and I really think the ethos and concept of Web3 is about publicly owned, community owned, and that's why we'll talk about public blockchains. So the Bitcoin blockchain is public. It's owned and used by everyone on the Bitcoin network, and anyone can be part of the Bitcoin network who chooses to be. I'm also seeing folks describing blockchain as a computer. And if you think about it, it is its own version of a computer. It's not a physical computer like I'm on right now. It's not like my laptop or a desktop or anything like that. It's a virtual machine, if you know what virtual machines are. So it's a something that's operating as a computer on one or more servers. Again, in this case of a blockchain, it's on many, many, many different computers at the same time. It takes input, and it can be, in the case of Ethereum, it can be programmed to perform a particular function. Bitcoin does not have that functionality, but Ethereum and others do, and that's what kind of makes them that development more interesting and more important. Provides an output. So the input, using Bitcoin as an example, is I'm giving 10 Bitcoin to Zach. Not really. There's no way I could afford that. I don't think I'll ever have that much money. But say I'm giving 10 Bitcoin to Zach. That keeps the blockchain keeps track of that. See Zach. And it provides an output saying it is now in the register that Matt, and it uses numbers for digital wallets. It wouldn't say Matt, but it say Matt gave, here it has Alice pays Bob. In this case, Matt pays Zach 10 Bitcoin. It's the output is on the blockchain. Everyone can see the record of the transaction. And therefore, my wallet has 10 less Bitcoin than it did before the transaction. It stores that data permanently, forever. And blockchains are, as far as we know so far, essentially unhackable. And I'm happy to talk to you about hacks that have happened. They've not actually been on the blockchains themselves. They've been on technology built on top of them that can be faulty, and that's how hacks have happened. We can come back to that later. But as far right now, blockchains are a very, very, very secure way of keeping track of something like Bitcoin or conducting other types of transactions. So again, we're walking through the transaction of me giving Zach 10 Bitcoins, or Alice, and then, we have a little logo here. I don't know if you can read that. It says Alice pays Bob 3 Bitcoins on this little example on the screen. How a cryptocurrency transaction would work on a blockchain is two people, have decided that, say Zach and I are emailing each other, and I'm paying Zach to purchase something from him or to purchase services or to pay for a class at Foothill. We decide to conduct the transaction, and so we share the public keys of our wallets. So I verify through a digital signature using my wallet that I want to send 10 Bitcoin from my wallet to Zach's wallet. And only I can do that with my private key and the digital signature that my wallet generates. The transaction request is broadcast to the network. And then the network validators, in the case of Bitcoin, they're called miners. So you might have heard of Bitcoin mining. They're verifying the signature. So they're making sure that I'm actually the owner of the wallet, saying to send 10 Bitcoin from this wallet to Zach's wallet. And that it's a valid I have the 10 Bitcoins to give him. It is my wallet. I can authorize it. They're checking all of that. And then they verify the transaction, they gather a group of those transactions. So this is thousands of these are happening, tens of thousands of these are happening every minute. And they grab a group of those transactions and they put it together in a block. They create a block either using proof of work, proof of stake, or another method of basically mining the block. And again, in Bitcoin uses proof of work. The block's then added to the end of the original chain. So you see this little chain above. So it zooms in here on like the block has a bunch of transactions on it, and they're connected together by a cryptographic hash. That's the little fingerprint icon. I don't know how well you can see it on the screen there. And that's what connects each of these blocks to one another in a specific blockchain like Bitcoin. And then the block's added to the original chain and it's finalized as part of the chain's history forever. Can't be changed. The technology does not allow for it to be. It is prohibitively expensive in the case of proof of work. And we can get into that on the next few slides. But I feel like I should kind of chunk this out and give you guys a chance to ask questions. I know there's a lot. I'm giving you a lot of information at once, and we're only kind of touching the surface of how all this works.
Yes, one question back here.
Is the third party involved in this in Web 3.0 because the third party can help people from fraud. For instance, when people transfer money to the other person by mistake, but the person who received the money didn't want to return the money. In this case, who can help people from help people get money back?
Did you hear that, Matt?
Well, could you summarize? I know it was a question about the third party involved, but I didn't quite catch the gist of the question.
She's asking, as an example, what if someone gave money by accident to someone else, and then the person who received the money does not want to give the money back, but the person who sent it does want the money back. So how would a situation like that work in relevance to this conversation?
Yeah, the way blockchain works, and people are trying to come up with solutions to make it more functional, so that you could have a dispute. But yeah, once it's sent, it's sent. It does not come back. If that person does not execute a transaction to send it back to you, then that's right. You don't get it back. So that's one of the risks. And that's if you're using non-custodial wallets. So we'll talk, that's if you're kind of operating on your own, again, doing the transaction peer-to-peer, me and Zach, no other third parties. We're doing it through the Bitcoin network. We are part of the network when we do that. The network is involved. We're not using an intermediary like a bank. And once that's done, yeah, if we have a dispute and I want the money back, Zach has to execute a transaction to give it back to me. There's not a Bitcoin authority. There's not customer service. There's not any, dispute process. It does not work like that. Yeah. So you have to be pretty sure, before you start, if you use a non-custodial wallet, that you know what you're doing and you know who you're sending it to and you mean to send it to them. It does happen. It does happen that people accidentally send it, or they might send it to a wallet, they get the number wrong. And who knows who actually has access to that wallet, then it's lost. So that does, that's one of many you're touching on, like there is problems with ways some of the system works. And there's people working on those problems. People are well aware of, people might have disputes and we might have to help resolve those. And there are a lot of people working on that. There are some solutions to that, but fundamentally, like at its core, if they're without any of those solutions in place, no, you can't, there's not a way to get it back. You can't reverse a transaction. That does not exist on blockchain.
Was there a follow-up question? And if so, just maybe speak just a little louder.
Yeah, actually, I got the answer. The person cannot get the money back. Nobody can help people get money back, right?
So in that situation, she's basically restating it. You don't get that money back.
Yeah.
Nope. Basically. Not unless that person executes a second transaction to send it back to you. There's no reversing. There's no reversal mechanism for transactions. Now, there is an edge case. I hesitate to go into it to not cause too much confusion. The entire network can decide to change the course of the entire blockchain. And there was one example of that in Ethereum. I don't think that has ever happened in Bitcoin. Well, no, it has happened in Bitcoin. I'm sorry. But that is a very, very rare occurrence where in order to undo something that happened on the blockchain, the entire network reaches consensus to change the entire blockchain going forward. That has happened, but it's very rare. And again, it would take like the majority of the network agreeing that that was the right thing to do with the entire blockchain. Does that make sense?
you.
On an individual level, no, that's not possible to reverse a transaction on a blockchain, not directly on the blockchain anyway.
Thank you, Matt. We have one more question in the physical room, and then I'll follow up with a question from Zoom afterwards, right over here to the left.
What do you think the future of Bitcoin is?
So the question is, what do you think the future of Bitcoin is?
Oh, I don't want to get into pontificating about Bitcoin if you're talking about like the price or anything like that. What I can say is that the future of Bitcoin is, I can say with near 100% certainty, permanent. Bitcoin's not going anywhere. I don't know what the value is going to be or if it goes up and down. I'm certainly not going to tell you whether I think where and when you should buy it, but it is a permanent fixture in our economy for sure, in my opinion.
Thanks, Matt. And
Yep.
a question from the chat is, per the topic we're kind of talking about, is this similar to Zealot? Once money is sent, you can't get it back. Are these transactions using blockchain as well? And if not, what is being used?
Zelle?
Yeah.
Was the question about Zelle?
Yes.
Zelle is traditional banking. It's nothing that, I mean, it was just a little bit of a new service to allow people to transact bank to bank, but you're still using the exact same infrastructure as if you were using Western Union. There's nothing different on the underlying technology there. So no, Zelle's not a blockchain. Zelle is not it's not revolutionary technology. Zelle is just a new twist on traditional banking services. That's all.
Great. Thanks, Matt.
Yep.
I think we're good for questions for now. Let's move on.
So again, so I touched on this earlier, like why blockchain is so, part of the things that makes it so special is its validation and security. And that was important again. So digital money could not exist if we had no way of verifying that someone has received or spent their money that everyone in the network agrees on. In Bitcoin, that's done through the proof of work. So proof of work is the miners, and you might have heard of Bitcoin mining and Bitcoin miners by now. They use powerful computers, and a lot of this is centralized now. Actually, the way that mining works, there's large mining farms that basically have really powerful computers to solve a cryptographic puzzle. And the winner of that puzzle gets to create the next block, gets to verify the group of transactions like we talked about before in a block. And they're awarded with some of the chain's token in the way that it's usually done. So you get a certain amount of Bitcoin if you are the one to verify blocks. Now, sometimes it's verified by a group of miners that share the prize. So they have these powerful computers working 24 hours a day, using large amounts of power. Bitcoin uses massive amounts of power. Proof of work is it works well and conceptually, and some people believe in it despite its environmental impact. But it is very, very energy intensive because you're talking about really high powered computers that are running 24 hours a day, and a lot of them that keep the Bitcoin blockchain running. And the security in it comes from the massive amount of work, the computations needed to arrive at the correct solution. So if I wanted to go in and I wanted to change the blockchain to give myself 1,000 Bitcoins, I can't do it because I would have to generate enough power to take over 51% of the network doing the cryptographic puzzles and get the network consensus to agree with me that my version of the blockchain was correct, where I have 1,000 Bitcoins in my wallet, I would have to dominate the network with so much power and resources. It's nearly impossible, even for a group of people to collude to do it. It would cost hundreds of millions of dollars in energy costs, and let alone the equipment costs for that. So that's why what makes it so secure is it's so prohibitively expensive to manipulate it. At scale, if you have a small blockchain, that's a different story. But Bitcoin had reached scale, and so that's what the scale of it is what makes it secure. Now, a different type that's kind of important to know about, there's several types, but the second most prominent type of consensus is called proof of stake. And that's instead of mining and trying to solve the cryptographic puzzles that take lots of computing power to solve, the individual nodes, and nodes instead of miners in this case, stake a certain amount of their token to become a node. So they basically collateralize the network. They put some of their own money up, and if they operate correctly and they truthfully, they get rewarded for mining blocks. If they are a bad actor and they're trying to change the network, they get what's called slashed or punished. They'll lose their stake. So and it's a fair stake size. I think it's 32 ETH in the case of Ethereum, which is a few $100,000. So you're incentivized to be a good actor as a validator, because if the rest of the network is saying, hey, Matt is sending bad transactions, my stake or my collateral in the network gets slashed. I lose a lot of money. And the network will know when you're putting the rest of the network's like, we don't see that transaction. I'm putting up some odd transaction that gives me a bunch of ether. The rest of the network's going to see that and say that's not correct. And immediately and automatically, I will lose my network investment. So an important thing to know about in blockchain, and especially with Web3. So up until now, I just wanted to touch on some of the fundamentals and where Web3 came from and where blockchain being an underlying technology, but where things really started becoming broader and more interesting, and really where Web3 comes from, started with the Ethereum network. So Ethereum is the second biggest blockchain next to Bitcoin. So Ethereum is number 2. And it was created mainly, there was a group of people I created, but the guy that's mainly credited with most of it is a guy named Vitalik Buterin. He was actually a guy that wrote and did a lot of stuff in Bitcoin. But he and others had a concept of the smart contract. They thought we should be able to embed code on a blockchain and allow a blockchain to run functions, to do more than just keep track of cryptocurrency. So in 2015, they launched Ethereum. And what Ethereum is a blockchain like Bitcoin. It has a native token, but instead of Bitcoin, it's called Ether on Ethereum. But it allows code, or what we call smart contracts, to be put into the blocks, and you can run operations on this code. So the blockchain can do an infinite number of things. It went from being able to do one thing, like Bitcoin does one thing. The Bitcoin network does one thing. It keeps track of Bitcoin. The Ethereum network could virtually, theoretically do almost anything you can do with code. And it can do it repeatedly, and it can keep track of how many times code is executed and how many times people use code and so forth. It's a virtual machine, and we call that the Ethereum virtual machine. And once the smart contracts are embedded, they allow repeated transactions of a certain type. So what are they most commonly used for? Creation of new tokens, creation of organizations that use a governance token. So we'll touch on that a little bit later. And blockchain-based governance. So using the tokens for voting, almost like shares, and having shareholders vote in a company, people doing that with tokens that they created using a smart contract on Ethereum. And this is also where we have meme coins like Dogecoin and stuff like that, unfortunately. That's kind of the underbelly and more of the negative side that I'm not going to spend a lot of time on, but happy to try to answer questions on it too. So these are a little bit, there's people that are dabbling and experimenting in this space, and there's been some progress, but here are some of our in real life applications or IRL applications that smart contracts could do. Storing and verifying credentials. So that there's a concept called the learning and employment record. So all of you as students should be able to carry around with you or store on a blockchain that only you have access to using a digital signature and a cryptographic key set, be able to store your credentials that verifies what school you went to, that you have a degree from Foothill, that you have certain work experience that's verified, that you have access to it. So instead of having colleges verify a degree, you own the verification of your degree. Or you own the verification of your employment record, that you worked for Acme company, for 2 years. They don't have to call the company. They don't have to verify it through HR. They could verify on a blockchain and you can give them access to. You can conduct a transaction that proves you worked for that company. Can also be used for sending payment for gig work and contracting, and allowing for digital ownership of real or virtual assets. That's where NFTs come in, for example. And there's all sorts of potential uses of NFTs. Buying and selling digital art, got a lot of attention, but that's just one of many things that can be done with NFTs, which are non-fungible tokens. So also, we won't spend a lot of time on NFTs, but if you take away one thing about NFTs, know that they are way more to NFTs than buying and selling digital pictures of apes. That is just a odd use case that got a lot of attention and a lot of money was spent on it. But that's not even scratching the surface of what NFTs can do or what their purpose is.
Matt, do you have time for a question real quick?
Yep.
So about the credentials, I know that MIT Media Lab did something about the giving certificate. Did any university start doing something in using this technology to give credential to students?
There were actually some grants that came out from the federal government several years ago. I haven't been able to track down what the result was, but I would look up the Blockchain Education Initiative. It came out of the Department of Education. They gave grants to some universities and colleges and some nonprofits, I think, to experiment with learning and employment records specifically. I don't know what the outcome is. Last time I looked, I was having trouble finding it, but just to learn about what they were doing. Yes, there has been some investment and work in this space. I have not seen someone come forward with like a high functioning solution, I guess. So it's still, somewhere between the conceptual and the actual here. Should it be able to be done? Yeah, I think it should be able to be done. Yeah.
Is there a follow-up question to that? No. He said thumbs up.
Oh.
And there's just one question in the chat, kind of, I think for either of us, you or myself, Matt.
These questions must be coming directly to you. I don't see them in the chat. Yeah.
They are.
Oh, okay.
Is there a particular academic pathway or upskill plan that would be a good way to delve into the learning and gaining skill sets in Web3?
Is there an academic pathway? Is that for
Yeah.
skill? Not that I've been able to find. I actually found Zach in the Emerging Technology Institute through trying to find that. I've seen two things. I've seen some community colleges in particular have courses on blockchain architecture or blockchain, but very much about the technology. So teaching coders how to code and create a blockchain, for instance. Very few. There was a course at, I want to say, is Long Beach City College, but it's not there. It's a defunct course that talked about Web3. I've seen very few courses that talk about the world, this part of the economy, like I was saying before. I think it needs to be created. That's part of, my drive in being here today with all of you. Is I do think there's a lot to learn here, a lot to unpack and a lot of opportunity in particular. And the space needs more builders, needs more people who to build it for the right reasons too, not to just generate more junk cryptocurrency. There's a lot of that, and that gets a lot of the attention in this space, unfortunately. But there's a lot of really good work happening that's going to create lots of opportunity, and that's what I'm trying to help people see and access and figure out. Hopefully that answers the question. So short answer, no, I don't. I've not seen a very solid pathway at a college, for instance, but I think there's plenty of good learning material to put that together. That's sort of what I've been starting to do. So.
Thank you, Matt. There is just one other question in the chat. What do you think about the future of Bitcoin ordinals? Which I don't know what that is.
I did see that. I'm not familiar with ordinals. So if they could clarify what they mean by ordinals. While we're waiting on that, a couple of just quick things I wanted to show you. How are we doing on time? So we still have a good 30 minutes, right? I want to make sure I can get through everything. So if you are this is just to kind of talk about how it's public and how all of the information, everything that happens on a blockchain is public information. Don't worry about trying to read any of this. It's going to be really hard to read on the screen there. But this is just to show Etherscan, and there's others, as a place you can go to look up the entire history of every transaction that's happened on Ethereum, all of the millions and millions. I mean, there's probably hundreds of millions or more of transactions that have happened on the Ethereum. You can find them here. The entire history can be accessed here. If you have, all you need is the public key for a wallet, and you can see how much money is in that wallet or how much cryptocurrency is in that wallet. You can see every transaction that wallet has made. You can see who they transacted with, and it's getting better about putting some of it in plain language instead of having to dissect or understand the numbers. There's more tags and notes being put on it, so we know who's transacting with who. But this is just to show that if you go to etherscan.io, you can look up any transaction that's ever happened on Ethereum with just some basic information about the digital wallet public key, for instance. Down here, we have the blocks. These are the numbers of the blocks. And if we clicked on a block, it would show us every transaction that was included in that block, what the consensus looked like, who got the reward for the block, all of the stuff we talked about before. It's all public information and pretty easy to get to with some kind of like simple learning a few things. The other thing that is kind of cool that I found that uses this information to visualize it is called etherviewer.live. And this is sort of a really cool visualization tool. And hopefully it loads for me. I don't know if it's if it's not, I have the link in there. It sort of they've taken all that information and they've made it into a visual tool. So you can see the Ethereum blockchain being constructed live. Every few minutes, a new block, I think it's more than that, maybe once a minute or once every 90 seconds, a new block is created. So these circles you see coming together, these are all the transactions that are being verified by the network. And then you see the transaction, you don't have to worry about reading anything on here, but if you see the little circles, those are all represent individual transactions. And then when they're brought together by a validator, they're added to a block up on the upper left. And then once that block is complete and verified, it moves to the right and becomes part of the chain. And so the history of the chain goes down to the right here. And then we start working on the next block. And actually, I think it allows you to click on these individual transactions. So you could see it'll reference probably in the Etherscan and what transaction this particular little icon is referring to. But just a kind of a cool tool that I think is useful in thinking about how the blockchain works. It's hard to tell from the Etherscan what we mean by blockchain. This actually shows you the blockchain for Ethereum. So I have the links here right here in the presentation that I'll share with all of you. Okay, so Ordinal's creating of NFTs, meme tokens, and metadata on Satoshis. I don't know that there's a lot of NFTs happening on Bitcoin. More that happen, NFTs are more purchased and sold, if we're talking about digital art, on Ethereum than Bitcoin. Same thing with meme tokens and that kind of stuff. As far as I know, you cannot create new tokens on Bitcoin. Bitcoin only keeps, like I was saying before, only keeps track of Bitcoin. That's it. That's all it does. The meme tokens, all of that stuff is generated through smart contracts on something like Ethereum or others. Because it's a public tool, anyone can go in there and create their own token. And if you can talk enough people into buying it, maybe you can make some money at it. But that's not really what the purpose of the whole network is. But people are abusing it in that way with meme tokens. I'll put it that way. Yeah, like any public tool, they call it permissionless. So there's no gatekeeper. There's no one stopping you or I or anybody else from going on and using it. So people are going to use it for good, and people are going to use it for selfish purposes or to try to make a quick buck. And that's what's happening with meme tokens, is people trying to quickly pump up the price of some token they created and then sell it as quickly as possible to take everybody's money. It's kind of like a penny stock scheme. If anybody saw the Wolf of Wall Street, those are the meme token creators of the Wolf of Wall Street, trying to get people to buy penny stocks and making money off them and then disappearing. So I wanted to, this is a new part. So, and hopefully I don't lose you here, but this is really to get it. Don't worry about remembering any of these names or understanding every connection and things I'm going to show here. More just to understand that there's a lot happening with blockchain. Like Bitcoin was the beginning, but Bitcoin was just the beginning. And with Ethereum and smart contracts, it's really exploded, especially since 2018 or so. There is a lot more blockchains being used in the world. And I wanted to touch on what that looks like. Very, very broad strokes. So there's what we call layer one blockchains. And so layer ones are blockchains similar to Ethereum that have smart contract functionality. You can put smart contracts into the blockchain on them. Near protocol, Cardano. Again, as a comparison, Bitcoin, you cannot put smart contracts in Bitcoin. It doesn't have smart contract functionality, at least not at scale. So when you conduct a transaction on any of these networks, you pay the network a fee. That's how the miners or the network nodes in Ethereum get paid. It's called a gas fee. It's paid in Ether. So as Ethereum, so again, like Ethereum is kind of like really the game changer, and it's still very, very essential to Web3, but I just wanted you to know a little bit more about other stuff happening in Web3. But as Ethereum started becoming more and more popular, and lots more people were using it, the number of transactions on it started to skyrocket. And most recently, around 2020, there were so many people using it and people competing for space on the block to have their transaction accepted to the block. The gas fees get higher and higher to do that, and it becomes an efficiency problem. And Ethereum was never meant to be just a big money maker for people that run nodes. So they immediately started kind of getting to work on trying to solve that problem. Like Ethereum's getting slower. It's getting very costly to transact on Ethereum when a lot of people are transacting on it at the same time. So two things happen. One, people start creating other layer ones like Near and Cardano. So other blockchains that do a similar thing to Ethereum. The other thing that started happening is layer twos. So Aurora is a layer 2 for Near protocol. The three in the middle here, Arbitrum, Optimism, and Polygon, those are layer 2s for Ethereum. Hydra Head protocol, that's a layer 2 for Cardano. So layer 2s are trying to solve the problem of inefficiencies and high gas fees in a different way. So they're kind of built on top of those technologies. So in the case of Optimism, for instance, it's what's called a roll-up. So it bundles transactions for a much cheaper fee and then rolls them back up to Ethereum. So you could do a cryptocurrency transaction on Optimism much cheaper than you can do it on the Ethereum network when the Ethereum network gas fee is high. And all those transactions get bundled up or rolled up into Ethereum. So there's a lot of activity. This is trying to solve the inefficiencies that have cropped up around the core technology, which is Ethereum. Now, Ethereum is still where probably 90%, if I had to guess, of the activity in Web3 happens, somewhere on Ethereum or on its layer twos. But there are other people trying to come up with alternate solutions. That's where we have these others on the side. And then one other that you might hear if you start reading more about this space is what's called, first, these are bridges. So if you had cryptocurrency on Near protocol, how do you get it to Ethereum, or how do you get something from Ethereum to Cardano? There's an application called a bridge, and bridge is actually the place where people have hacked blockchains because they're way less secure than the blockchains themselves, these ways of moving stuff from one blockchain to another. And bridges are actually also the way that a layer 1 and layer 2 are connected, is through a bridge technology. Last thing on this is layer 0. So another way of solving kind of the inefficiency, high gas fees, high transaction volumes, slowing down the network, can only do so many transactions per minute, is what's called layer 0. So Polkadot's an example of a layer 0. And what Polkadot is it's a network of individual blockchains that all have the same underlying technology, which is Polkadot, but it allows people to create their own blockchains with different purposes or different functions. Or you might want a blockchain to keep track of NFTs, and someone else wants a blockchain to keep track of learning and employment records. But you want those blockchains to be able to work together without a bridge, because again, the bridges are very fallible. It's kind of a main point of attack for bad actors are bridges. And so layer 0s are solving that by eliminating the bridges. They're all built with a similar technology, so you can have different blockchains that communicate with one another. All right. My next topic is going more into cryptocurrency, but I will pause here for any questions. Again, I wouldn't worry too much about the individual names or all of the things I said, but just to know there's a really big ecosystem of blockchains now that is growing. And a lot of different kind of interesting solutions to make it more efficient, to make it more functional for people, make them more useful.
There is one question in the crowd.
Yep.
Maybe it's not directly connected to this, but
Speak up. Just speak up a little.
Is it okay if the question is not directly connected to this? I wanted to ask something about the idea of no one left behind, or how's this going to... sorry, I'll
That's okay.
I'll ask that question. So, do you think that this idea would be incorporated in the daily life as the idea of ubiquitous computing, or is it just a one form of the way to do government, or just one tool? Does it make sense?
I'm not sure I'm understanding the question.
You're asking it's a government tool?
No.
Oh.
Maybe think about it and rephrase it. We'll come back to it.
Yeah, we can come back. I know it's a lot. There's a lot in this presentation too. So I'm trying to touch on some key concepts without trying to make it too much. And so feedback is also, if you also please do tell me if it's this is too much for one 90-minute session. That's good feedback too. But let's just touch on cryptocurrency for a moment, because cryptocurrency is a fundamental part of how blockchains operate. It started with Bitcoin, and every blockchain has its own what they call native cryptocurrency. And it also usually handles a number of other types of cryptocurrency or tokens. And so it's important to kind of know about it. It's sort of part of how they function. And really three things that I think are important to know when we're talking about cryptocurrency is the first thing is that digital asset is probably a better term for that. And you'll see that I change it to digital asset later in the presentation here. That can be spent or sent peer-to-peer, semi-anonymously, and without an intermediary like a bank. So like we were talking about before, Bitcoin was created because there was a group of people who thought we should be able to have a digital form of money to share with, to send to one another without the use of, without needing a bank or a government. It doesn't have to be the US dollar, or it doesn't have to be a euro dollar or a yen or anything. It's going to be a new form of currency that we use to pay each other for various things or to work together on a project or what have you. The currency part of cryptocurrency is a little misleading, which is why digital asset is probably a better term. You'll hear that used too. It's because it's really a new type of asset. It can be used for other functions like voting. And so there's something called a governance token. That's a form of cryptocurrency that can be used to vote, like if you're a shareholder in a company, or to prove ownership of an asset. And that's one of the functions of a non-fungible token, is to show that you own something. And at its core, it's a tool to allow Web3 to function independent of centralized organizations. So in order for this network, this peer-to-peer network as Web3 to exist, there needed to be a way to create and share value with each other without having to use traditional currency and without using traditional banking systems. This is just a brief history of cryptocurrency, so I'm going to kind of pass this because we talked about most of it, Bitcoin being created. There were other coins that were created on other blockchains like Litecoin and Ripple. Talked about Ethereum starting in 2015. And also in 2015, we had our first stable coin. And that's kind of an important concept because, as you may know, if you've read anything about cryptocurrency, you'll know that it's very volatile. It goes up and down, especially we're talking Bitcoin or Ethereum. They go way up, they go way down. They're not really reliable. If I want to pay you for a service and I want to pay you the equivalent of $100, I might pay you something that's way below what I mean to pay you or way above, depending on if I'm paying you in Bitcoin. A stable coin is always worth $1. Usually it's tied to the US dollar. So one tether, or it's the symbol for it, or the shorthand for it is USDT, is always worth $1. Never changes. And there's a number of them now. There's several different stable coins. But then in 2020, we had the first layer 2 we talked about. Polygon was one of the first ones for Ethereum. So here's where I switched over to calling them digital assets instead of cryptocurrency. Partly because cryptocurrency, I think, has been getting a bad name because of the scams in it and because of meme coins and all the other, less than benevolent functions that have been out there. But digital assets can be used as actual currency, especially when we're talking using stable coins, because they're worth the same as dollars. It can be used as an asset to store value. So a lot of people think of Bitcoin as something that stores value, like digital gold. So people that aren't interested in investing in gold, they might invest in Bitcoin. Not advising that, but that's store of value is another function. Or it's used to perform a function. So to pay operators of the network, to give voting power in the case of a governance token, to give sometimes NFTs are used for access, like basically your ID card to get into a community might be an NFT, a non-fungible token. So yeah, those are the slides I have on cryptocurrency. So I'm happy to answer questions about cryptocurrency.
We got one question over here in the
Everybody's
corner.
gonna have to. So I'm trying to wrap my head around the value of cryptocurrency or crypto asset or whatever it's called. So the currency, the value of it is only between the network of people who uses it. You can't take it outside the network for actual currency someplace.
Were you able to hear that?
You can exchange it for there are it's more or less digital banks that will exchange cryptocurrency for US dollars.
Is there a maximum and a minimum to the amount, or the minimum is obviously $1, but the maximum, could it be in the hundreds of thousands to millions to billions?
Yeah, there's no I mean, if you're talking about the process of converting a digital asset, to US dollars, then there might be some restrictions on the bank you choose. Coinbase is one. Another one's called Kraken, Binance. There's a number of them that would make that exchange for you. They might have their own rules or governance that might restrict what you're saying, like the volume or the amount they would do. But within Web3 or within the blockchain, no, there's not there's not an Ethereum council or board of directors that makes rules about Ethereum. The network comes to consensus on guidelines and rules, especially usually with relation to how the code works. They kind of put their rules into code, right? There's not so much a laws in it as there is code. We think the Ethereum network needs to do this, that, or the other. They all decide that Ethereum network votes on that as a network. When there's changes made to the Ethereum blockchain, there has to be consensus in order for there to be changes. Is that helpful? So there's a kind of a difference there, what you're talking about, what happens within Web3 versus then trying to take value from Web3 and put it into our traditional economy or put it into your personal bank account. Yes, you can do that, but there's
Yeah, like how banks sometimes use standby letter of credit, like SBLCs, and I've heard people kind of interchange SBLCs and Bitcoin, with specific banks like central banks. But then, and all that's based on blocks of data to make the blockchain or the code for the value of the coin. I know it's more integrated than that, but basic, right?
Yeah, they would make an exchange based on the market value. You can look up the market value anytime. Same you can as a stock, what the market value of any, or, the majority of cryptocurrency is. And that's what, they would make the exchange based on what the markets are saying it's worth.
Thank you, Matt. We have one more question right here.
So back in 2022, I heard that there's people using these digital assets to purchase things and basically live with these by backing the US dollars. Has anything happened to those people, or is there a trend in using these assets only? Or do you know anything about
it? There are some of the central banks we are talking about are like the crypto banks are offering ways to spend your cryptocurrency at a store with a card. Basically what's happening though is they're converting on the back end, they're converting it to US dollars. And then, if you're buying at a store, when you make the transaction, they're debiting from your account, the cryptocurrency, they're exchanging it into US dollars and the store's getting US dollars. But yes, there are people that are making it kind of easier to spend it in the real world. Yep.
I have a follow-up.
Follow-up question?
Yeah, so how long do you think it's gonna take until these assets are directly used, are more common to use directly rather than converting to US dollars?
Yeah, one takeaway I would like, I guess, everyone to have is there's millions of people using them every day right now to buy and sell things, to be paid for work, it's happening now. It's not as widely understood or followed as it could be, if that helps. That's already happening, to answer your question, to a pretty large degree. Yeah.
Thank you. We have another question
Yeah.
over here.
That is kind of a follow-up to the last gentleman's question in terms of the use of this around the planet. So do you see what regions around the planet may be a lot more active using these digital assets than other places? How pervasive is it around the planet?
It's a very rough answer to that is it's pervasive everywhere. China has a lot going on with cryptocurrency. I think the last I checked, the vast majority of Bitcoin mining happens in China and like computers in China, for instance. Despite the fact that the Chinese government has cracked down on it and said and has I think banned it, but it's not something they could easily stop just by banning it. So there's a big hotbed in China. Europe has been a little more open to allowing people to build in this space and to create new technology. The US has been a little more restrictive so far. And there's more companies going offshore to Virgin Islands or Europe or other places to centralize just because the laws are very vague and not clear right now in the US. So that's one of the risks. And I like to kind of there's a section I'm probably gonna have to miss here, Zach, but I probably should touch on the risks since we're already getting to that part, which is towards the end here. So I'm gonna skip ahead if that's okay.
Yeah, no problem.
Yeah.
We only have a few minutes left, so I think if Matt can just kind of talk about the risks real shortly, and we could wrap up.
Because that's what we're getting to anyway. So let me do a quick skip ahead. There's a lot more about kind of the work in this space that I would love to get into sometime. Maybe that will be a follow-up or something, Zach, but I do want folks to kind of be aware of risks before we go. So you've heard me mention this a bunch of times. There's a lot of scams, and they're different. It's a different space. And the scams are different and they're much easier to fall for. You have to be very careful if you're gonna go into this space right now. There's a lack of regulation, which I have on the next slide, I think, and that makes it hard to find the bad actors. There are ways to do it, and they do find bad actors, and people are held accountable, but you have to be very careful. And one rule of thumb is if like you decide to look into this more. If someone shows up offering you an investment opportunity, I can almost guarantee you it is a scam. The real investment opportunities, they don't knock on your door to offer you. That doesn't happen. So you can ignore anyone trying to get you to buy a random token of some sort. The price of tokens change drastically. So it's volatile, like we talked about. So there are people being paid a salary in cryptocurrency, but you have to be very particular on what you get paid and how. You could ask to be paid in stablecoin. That would be much safer than being paid in Bitcoin, for instance, because the price changes drastically. And it's very easy to make mistakes when you're conducting your own transactions. So we didn't get to talk about non-custodial wallets, but that's like a way to actually do peer-to-peer interactions without the use of intermediary, but it's risky right now. So those were more like risks related to cryptocurrency. General risks, and this is why I want to get here. It's limited to no regulation in the U.S. yet. They're kind of treating cryptocurrency and digital assets like traditional money and stocks, and it doesn't make sense at all. And it has all sorts of contradictions and problems. And it makes it riskier because, again, it makes it easier for the bad actors to operate and get away with it. And so it's something to be aware of. Someone asked about this earlier. How do you reverse a transaction? You can't. If you do it peer-to-peer, you don't use Coinbase, but you do it peer-to-peer using a non-custodial wallet. There's no reversal of transactions. There's no customer service for Ethereum. There's no insurance to cover the loss of money out of your wallet. We didn't talk about DAOs, but they're still new and therefore not stable. So if you worked with a decentralized autonomous organization, you have to be careful on that. And instead of trusting people, I'm going to skip the anonymity part, but trusting the code is what we're doing in Web3, the smart contracts. So instead of trusting people, we're trusting code. And so when you're working with a smart contract, has someone checked that code and made sure it does what they're telling you it does. If you don't know what the code does, you probably shouldn't be interacting with it. Again, this is just like kind of a broad overview to help folks understand the broader space, but I know we're at time, so I'll just point out that towards the end, I will share this deck. I have some links for Harvard Business Review does a really great series on Web3. Bankless Publishing puts out a lot of really good content about Web3, and I recommend them in general. Coursera has a whole online course you can audit for free on decentralized finance that talks a lot about how blockchain works, and it was really essential to how I learned more about blockchain. I just went in there to audit. You can audit the course for free. You don't have to get the certification, but and I'll leave it there. And that was my question slide, but
yeah, thank you so much, Matt. We really appreciate you coming. I know there's one more question in the crowd, but I want to just say thank you so much. And I did have myself, I had a quick question. What happens if, say, you're saving some cryptocurrency in some wallet and you lose access to the wallet, some user? Is that gone forever?
Yep, it certainly is. Yeah, there's it's a very well-known problem. There are wallets that were lost early on that now have the equivalent of millions of dollars in them, but no one has the private key. The private key was lost. So there's people that are trying to come up with ways of backing that up. I mean, the easiest way to back it up is to have someone hold it for you, right? But in decentralized Web3, you may not want a centralized entity to hold on to. So people are trying to come up with ways of having backups. And a lot of these wallets, when you create them, it will create multiple backups that only you have access to. So there are solutions for that. But yes, if you absolutely lost your private key in what's called a seed phrase, you lose access to the wallet in a non-custodial wallet.
All right. Well, I think we're just about out of time here. So I want to say thanks again, Matt. This has been really informative, especially about technology that I think is misunderstood and actually not as widely publicized as many of these other emerging technologies out there. So we really appreciate it. Let's give Matt a round of applause.
Thank you.
Yeah.
Any question on how we get the slides? I will make sure Zach, I'll get them to Zach to get to you guys.
Yeah, we will distribute those slides to everybody that is in the Zoom and in person as well, as long as you wrote your emails over there. But other than that, Matt also posted his website at the beginning of the chat, Map Advisor. So, you can get a hold of him that way as well if you'd like. But other than that, we're out of time. We got to get going. So until the next ETI workshop, we really appreciate it, and have a good rest of the day, Matt.
Thank you, everybody.
Thank you.